Hey Thinksters, and welcome to this video where I want to show you 3 methods how to join pairs in a Python list, pairs of elements in a Python list. So I think this is best explained by example. Say you have the following list of 4 strings, and now you want to join pairs of those strings, so the first and the second string and the third and the fourth string. And if you would have more strings, then you would again try join more and more pairs of those strings. And for example, another example is, so basically this one here, you would expect the result to be a list with 2 elements, the first one being xy, which is like the two values, these 2 values joined, and the second one is vw, which is like the third and the fourth element joined in the Python list. And then of course another example would be the following list here with some uneven number of elements. So how again you want to join the first and the second element, the third and the fourth, and the fifth and the sixth element. And I think by solving like small problems like these, you will just become a better coder overall. And yeah, we will look into different methods of accomplishing this. The first method uses the zip function. So like the first method is based on the zip function. The second method is based on an iterator. And the third method is based on indexing, and all of those methods use list comprehension. So basically, if you follow me along for these methods, you will understand the zip function better, you will understand how the iterator works, and you will improve your indexing and list comprehension skills. And these are like vital skills for a Python coder, so keep watching if you are interested in improving your skill set. Okay, so the first method, so we create a variable out, and this variable out is a list of values, and this basically in one line we want to create a list of these pairs. So we want to pair these elements in the list. And how do we do this? Yeah, we use simple list concatenation of 2 values x and y. Okay, so we concatenate 2 values x and y, but now we need to define them. In list comprehension, the first part is the expression part. This is the expression part where you do something with some variables. Yeah. So what do you do in this case? Yeah, you use the plus operator. The plus operator on strings means concatenation. And this is what we want to accomplish. Yeah, we want to concatenate those 2 elements together. And now we need to define those elements. So we need to, in this comprehension, we need to define the expression, which we have done, and the context, which we will do now. So the context gives us the definition of those variables x and y. And we want to iterate over all x, y's in our zip, and the result of our zip operation. And the zip operation now takes 2 iterables and zips them together. The first iterable is the result of the slicing operation with default start and stop index and step size 2. So we take every second element. So the result of this part will be the first element, the third element, the fifth element, and so on. Okay, and the result of the second slice operation, it starts with index 1 and then it takes every other element. So index 1 is the second element in the list, so it starts here and then takes every second element. So it goes to the so it starts with the element with index 1, then it takes element with index 3, then 5, and so on. So basically we take those together and now we zip them, which means we pair together, for example, so we pair together this first element with the second element. And then we pair together the third element with the fourth element. And this is like how the zip function works. So it if you have 2 parallel structures, let's maybe have a drawing board where I can explain it better to you. Okay, so you have some elements, say 1, 3, 5. This is based on the slicing operation, and then we have some other elements like 0, 2, and 4. And now zipping them together means that we pair like the first element of the first sequence with the first element of the second sequence, and the second element of the first sequence with the second element of the second sequence, and the third element of the third sequence with the third element of the second sequence. Okay, and we pair them together in tuples, so these are now tuples, and the result of the zip function is an iterable of tuples, and this is exactly what we want to do here. Yeah, so we want to pair together pairs of elements in our original list. And now, so we zip them together, we iterate over the tuple values. So the result of the zip function is an iterable of tuples. Now we catch the first tuple value in the variable x and the second tuple value in the variable y. And now what do we do with them? We concatenate, as I've already discussed, okay? And this basically already solves the problem. It's a very nice Python one-liner, and it has different parts of your understanding in Python. So you need to understand slicing, which we used here. You need to understand the zip function. You need to understand list comprehension. But then if you understand those things really well, then you can basically solve these problems very effectively in Python in a single line of code. I don't think there is a programming language that is as concise as Python to solve these kind of problems. Okay, so let's execute this and see the result, x, y, and v, w, which is exactly what we want to accomplish. Let's check whether it also works on more complicated lists like this one. Okay, it seems to work. So we here we pair together the a's with the b in one value, the c's with the d in one value, and the e's with the f's in one value. So this works beautifully. Good. Let's. So if you like one-liners, then check out my new book, Python One-Liners with no starch press. I just released it. It's fun. It consists of many lines of code. So I have also many graphics and code discussions, and it's a very practical approach to computer science where we address different areas like machine learning, data science, regular expression, basic computer science theory, algorithms, Python basics, data structure. So we address all of those things, but always have an eye on a single line of code. So we develop a lot of like 50 or 60 one-liner solutions to different problems, and it's just fun. You will learn a lot. So get the book, Python One-Liners with no starch press, and yeah, check it out. So let's dive into even more solutions for this problem. So a very efficient approach that an advanced Python coder may consider is to create an iterator. So an iterator, the advantage of an iterator over a list is that you can also iterate over the iterator. Obviously, it's an iterator object after all, but it doesn't generate all the values in advance. So it doesn't store these values in memory. So for example, if you create a list of values, then so like this, say a list of values 1, 2, 3, and so on until you have 1 million. Yeah. So say you create this list and it's a list of 1 million elements, and an iterator would not create all those elements in advance. It would only create the element if it needs it. It only creates a current element. So if you iterate over this list, you would create the list once and store it in memory, and your memory is now contains all these elements. So your memory is cluttered with all the information it doesn't need currently. Yeah. This value 1 million, it needs it only if it needs it only one time if you iterate over the list, and this is in the end. So you could dynamically create the element you need, and this is done by an iterator. So the iterator needs to define the next function, as you see, and the next function will then just take the next. So the iterator always has a pointer. This is currently at this element, and now if you call the next function, then they move the pointer one step to the right, and the next function then creates the next element dynamically. So it doesn't create the element at once in the beginning. It creates it dynamically as it goes over the element. So it's more memory efficient. Okay, and then you can do something similar. You create an out variable. You use list comprehension with simple list concatenation. But now instead of taking the value y, you call the function next on your iterator. And if it doesn't exist, it's just an empty string. And so by calling this function, you move one step to the right in the iterator. So you take the current value x. X you still need to define, but then you move one step to the right, okay? And then you go to the next element x and so on. And then you iterate for x in the iterator, obviously. So it basically starts with the first element in your iterator. This is x, and then it concatenates x with the next element. But now the iterator moves one position further. It already moved one position further. So if you now take the next element in your iterator, next time the x will be the third element. Okay, so like x will be every second, x will take every second element, and you will always have one element in between, which is catched by this next function call. So you see, it's even more concise, it's more efficient, and it works beautifully. So if you print the result, you see it produces exactly the same result. So this solution, it's very Pythonic, very advanced solution, and I'd recommend it actually for, so if you are beyond beginner level, you can start thinking in those terms, yeah, like what is a memory efficient way of doing it. But of course, it may hurt readability if some beginner coders, they don't really understand what the next function does, they don't really understand what is an iterator and so on. And also you have to create this helper variable, so you cannot create it dynamically. Why? Because you need the iterator 2 times in this one call, so you cannot just create it 2 times dynamically. Then you would have created 2 iterators that are independent. But the beauty here is that they are dependent. So if you call next on the iterator here, it will have effect on the context part of the list comprehension statement. Yeah, so so the next element x will be one step further than the last function call. Okay, so the third method is it's a very simple method. This is a method many many coders that come from other programming languages would use. You create an empty function. You still use list comprehension, but you use indexing to access the elements. And which elements do you access? Yeah, the ith element of the sequence and the i+1 element of the sequence. And then you could just go for I in range. And now I need to get rid of my face. For I in range, and yeah, you go from 0 to the length of your list. So you want to take all elements, but you take only every other element. Yeah. Why only every other element? So with the step size 2, because you concatenate these elements here. Yeah. So you concatenate an element with index I with the element with index I+1, and now of course you cannot take this element with index I+1 once again. So it's the same problem as here. Here you solve it with an iterator. Here you solve it just by taking only every other element in the sequence. Okay, so this also works beautifully. So if you print the result, it creates exactly the same output. So all 3 methods are semantically equivalent. The most efficient one, most memory efficient one is this one, the iterator. And yeah, I would say the most readable one for most is this SIP function with slicing. If you don't come from Python, so if you are, let's say, a C++ or Java coder, then this indexing method may come most natural to you. Okay, so thanks for listening to this video. Again, check out my book, Python One-Liners, if you want to improve your one-liner superpower, and see you in the next video. Bye.